Very happy good evening to all of you, beta. Very happy good evening. Divyan, Shiva, Tarun, Shushut Nandi, Kyadash, Ayush and all. How are you all, beta? कैसे हो आप सभी? First, everyone, beta, please confirm me audio and video is crystal clear to all of you. Can we proceed? Very happy good evening, beta, Mehna. Crystal clear, sir. Okay, fantastic. So, now we are in lecture number 10. Today, we will discuss especially collision theory and transition state theory and numericals. Okay, once again, you're all welcome. As you all know, this side Gaurav Srivastav sir from Engineers Institute of India with 14 plus years of teaching experience as GATE Chemical Engineering Author Educator. Multiple GATE top ranks. This year rank AIR 43. Okay. Uh, ये कौन है जानते हो? Who is he? Guess. Henry Eyring. Henry Eyring. Who is Henry Eyring? Transition state theory given by him. And this name is important because sometimes the equation that you are going to use from transition state theory, that equation also known as Eyring equation. If someone asks you what is Eyring equation, so Eyring equation is nothing but it is the equation that you are going to use in transition state theory. Okay, so today's first topic is collision theory followed by transition state theory. Till now, you had seen first theory, Arrhenius theory, Arrhenius law. So first beta, please everyone one more time tell me in comment section. There is no doubts. उसमें कोई doubt नहीं है किसी को बेटा, please everyone tell me. No doubts in Arrhenius theory. Can we proceed? Crystal clear. Okay, very good. So you had seen in Arrhenius theory only and only one thing where Arrhenius mainly focused, and that is at the time of collision reactants must possesses their respective activation energy. He didn't told anything well or in detailed manner like how they are going to collide or what is the effective collision. These things discussed in detailed manner in this collision theory. Collision theory independently given by two scientists in the early 20th century. One work published in 1916, one work published in 1918, one in German, one in British. Max Strauss and William Lewis. These two names are especially important for PSUs as well as for GATE examination because already asked lots of PIQs like one PIQ was condensation theory given by Nusselt. So these type of questions already asked in your GATE PYQs you can see there. So name is also important here. Name is also important here that who had given collision theory. Now, what is collision theory? Very, very easy theory. Previously, you had seen that if this is a molecule A and this is molecule B, they want to react. They want to react. So, if they are going to react and they collide in not a proper orientation, my dear students, what is going to happen? Reaction not happened there. Reaction not happened there. Again, they collided one more time. This time, they collided in properly oriented manner. Again, my dear students, reaction not happened. But one more time, when they are going to collide, again properly oriented manner, they are again collide in properly oriented manner. And my dear students, this time reaction happened. What I want to tell you, beta, in first one, in first one, properly orientation, orientation is there in first one. No, they possesses their respective activation energy at the time of collision. They possesses their activation energy at the time of collision. It may be yes, it may be no. Even if they have their respective activation energy, but they are not properly oriented towards each other, reaction not going to happen. This time, my dear students, properly oriented, yes, but still reaction not happened. Why? Because their activation energy is not available with them. In third one, my dear students, properly orientation is there, activation is also there, and reaction happens. So this, out of these three collisions, my dear students, only this collision is known as effective collision. This collision is known as effective collision. Okay, so this is all about your collision theory. This is the main things that you had seen here about collision theory, that reaction only and only happens when they are going to properly oriented along with their respective activation energy. Okay, in previous case, Arrhenius didn't told too much about how they are going to collide or anything about effective collisions in detailed manner. Okay, a few main assumptions I am going to show you here. After that, some more points about this collision theory I will discuss. First, I am going to discuss what are assumptions and their limitations. Very, very important. Okay. So, see, please note down each and every assumption. I am going to discuss one by one each of them. Okay, one by one each of them. So, my dear students, first assumption that you are going to see here, hard sphere molecules. This assumption taken inside collision theory, that reactants are modeled as rigid and non-attracting spheres. Rigid reactants are rigid. Reactants are rigid one. Okay, as well as non-attracting spheres. Attracting spheres. What is the meaning of non-interacting? See, number 4 along with number 1. No intermolecular forces. You know, my dear students, that if two molecules are there, definitely intermolecular forces are there between one single or between inside, that is intra, and between two molecules, that is intermolecular forces. इन हिंदी इफ यू वांट टू फील बेटा, तो आपस में एक दूसरे को आकर्षित करते हैं, वो क्या कहता है आकर्षण फोर्स, इंटरमोलिकुलर फोर्सेस कहलाता है. सो यू नो इंटरमोलिकुलर फोर्सेस आर देयर, but in collision theory, totally neglected. That is, forces between molecules are negligible except during collision. मतलब आपस में जो टकरा रहे हैं, this is the only force. There is no collision because of their intermolecular forces. So totally this force neglected in this collision theory. So that's why here I am writing with a non-attracting spheres. That is, no intermolecular forces between reactants. Between reactants. Between reactants. Only they are going to collide with each other because of their respective collision is going to happen because of their respective kinetic energies. One more time, but please tell me everyone. Number 1 assumption, number 4 assumption. Is it crystal clear to all of you? Assumptions means what? Beta, मान लिया. ऐसा माना गया. It is not reality. It is just assumed inside this theory, and definitely anything if you are writing in assumption, that is your limitation. That is the limitation of your theory. Okay, beta. Very easy, na? Okay. Now, see assumption number 2. Collision requirement. The same thing that you had seen in a previous one, that a reaction is going to occur only and only when collision is going to happen. So very easy. But all collisions are not going to become effective collision. Only the collision when energy threshold is there, like colliding molecules must possesses their energies above their average energies, or you can say in simple language, they must possess their respective activation energies. So they must cross their energy threshold. Only in this manner they are going to react. Maxwell Boltzmann distribution, same to same as you had seen in a previous case. Here also the same. Molecules, how kinetic energy distribution between molecules are going to occur, the same thing used, that is Maxwell Boltzmann distribution. And this is fourth one, this is fifth one, this is sixth one. And the fourth one is what is steric factor. I will give few more details about this steric factor, but the things only here I want to discuss that all collisions are not effective collisions. Collisions must have their proper orientation, and the steric factor is directly related with effective collision. What is the steric factor? Don't worry, I will discuss just after 4 or 5 minutes with equations. With equations, simplest equation for steric factor. Okay. So clearly you can also write limitations like hard sphere approximation. Here you are going to ignore totally that any intermolecular forces are there or any molecular complexity is there. And the second one is solvent effect. What is the meaning of solvent effect? Clearly, my dear students, here the things that you are going to write is you are telling that everything is going to occur according to kinetic theory of gases. See, Maxwell Boltzmann distribution. It is also the basis of kinetic theory of gases. It is related with kinetic theory of gases. So, collision in collision theory, it is going to follow. It is totally and totally based upon kinetic theory of gases. And if it is based upon kinetic theory of gases here, then if in any reaction some liquid is there, some solvent is there, so definitely some more modification required. And in that case, even if you are going to calculate, you can calculate, but error is more. Error is more. So only and only its validity, or you can say accurate, it is accurate for gas phase reaction only. For gas phase reactions only. Why? Because it's totally based upon kinetic theory of gases. If solutions are there, then modifications required. So one by one, I discussed all assumptions, limitations. I hope very easy. So please one more time, beta, tell me, is it crystal clear? Can we proceed, beta? Can we proceed and see this collision theory in more detailed manner, yeah? Everyone, please tell me, beta. So overall, you can say it states that particles of the reactant when particles of the reactant collide with each other, only a certain fraction of collisions cause the chemical changes. These collisions are known as successful or effective collision, as I told you earlier. So I think this point is crystal clear to all of you. Okay. Now see next point. The effective collisions must have their activation energy at the time of impact with proper orientation to break the pre-existing bond and form all new bonds. The same thing as I told you in this slide beta. This is about effective collisions. About effective collisions. When it is effective, when they have properly oriented as well as the activation energy is available with them. Okay, beta. So point number one, point number two, and point number three. I hope everyone crystal clear. Okay. This one is also crystal clear. These 3 points I will discuss later after a few more important discussions about this collision theory. So till now the things that you got only that effective collisions are responsible for reaction inside collision theory. Please listen carefully, beta. Things are very easy. A little bit theoretical, after that mathematical. Okay. Now, if you want to write for for collision theory, if you want to give that temperature dependent form, you want to give temperature dependent form. Previously you had given in simplest equation here like k is equals to k naught e raised to power minus ea by rt. You had seen na beta for Arrhenius. For Arrhenius equation, you had seen that k can be written as simply k naught e raised to power minus e by rt, minus e by rt, or you can say e by rt. E is activation energy. When you are going to write the same equation for collision theory, then equation is little bit different. Here you have to write k is equal to z rho. K is equals to z rho, then e raised to power minus ea by rt. Now, in this equation, what is z? What is rho? Don't worry, I am going to tell you one by one. Okay. Here, my dear student, z is known as collision frequency. This z is collision frequency. ये z क्या है बेटा? z आपका collision frequency. Okay, z is collision frequency. And if you are going to calculate this z, the calculation of z is a very complex for you. Like one simple example I am giving you. Z is equals to n. Just z can be written as na. Here beta na is not a molar flux of a. Na is Avogadro's constant. What is na? Na is Avogadro's constant. Avogadro's number, the same number that you had seen, 6.023 into 10 raised to power 23 मोल इनवर्स. ये जानते हो ना बेटा सभी लोग, पढ़ा हुआ है ये. So n is sigma ab. Now what is this sigma ab? This is cross section of collision. ये क्या है बेटा? This is cross section of collision. This is cross section of collision. That means when collision is going to occur there, when collision is going to happen there, what is the effective cross section from which collision happens? And if the diameter of particles given as simply you can say DADV, if the diameter is written as DADV, so you can also write in terms of dias. Pi d a b square, where this DAB is simply the arithmetic mean of dias of A and B. Like suppose here reaction is going to happen, A plus B forming products. A plus B forming products. Okay. So this is your sigma AB. Now 8 kBT root over 8 kBT. You know what is KB? Boltzmann constant. Can you tell me better the value of Boltzmann constant? क्या आपको याद है किसी को? Any one of you? Boltzmann constant. किसी को याद है आप में से बेटा? Boltzmann constant. The value of Boltzmann constant. Very good. So 1.38 into 10 raised to power 23. Confirm beta. Is it 10 raised to power 23 or minus 23? Please confirm it. Sushmit Nandi? Minus 23. Very good. So 1.381 into 10 raised to power minus 23. Absolutely correct. Unit is joule per Kelvin. And no need to remember the values of Boltzmann constant, etc. If asked in examination regarding anything in any subject, then they are going to provide these values. Don't worry. Okay, but Avogadro's constant you need to remember. Now, one more thing here, and the most important thing on which they can ask you question, that is mu a b. इस पे आपका क्वेश्चन पूछा जा सकता है from collision theory. So my dear students, mu ab here is known as reduced mass. It is known as reduced mass. Like if mass of a is ma, if mass of b is mb, then 1 by ma, 1 by mb and whole reciprocal, this is known as reduced mass. Actually, what mass is responsible especially going to affect that collision? That is known as reduced mass. So like one question beta, if I'm asking, suppose in your examination they are asking about this reduced mass. If they are saying if ma is much higher than mb in collision theory, then reduced mass is nearly equals to, immediately please tell me, is it ma or mb? If ma is very large, then reduced mass is nearly equals to ma or mb. Immediately I want fastest answer, yeah. Please everyone tell me. Everyone please tell me. If ma is very large. Shiva Tarun MB, confirm. Mena MB, MB. Okay, everyone telling MB. Why? Because if MA is very large beta, then 1 by MA, this term will become very less. If this is very less, so you can neglect it. So 1 upon MB, that will give you MB. So these type of basic questions already asked in PSUs. So it can be asked in your GATE examination too. Okay. So please tell me, beta, till now the things that you had seen, is it crystal clear? And one more thing, beta, the equation that written by me for Z, this is not every time will remain same. Like if you are going to change reaction from A plus B to product to A plus A, this is 8 when A plus B is forming product. Okay, A plus B forming product. But when A plus A is forming product beta, then in that case this 8 is now going to become 4 there. ये 8 से 4 हो जाए, then 4 kbt upon pi mu ab. That means this is a very complex thing, and this is the statistical approach. And you are undergraduate engineers, so mostly the things that you are going to see, macroscopic approach, like classical thermodynamics you are going to study. Statistics, thermodynamics you are not going to see. This is not your syllabus. Okay, so the derivation or the equation that I'm writing here for Z, this is not empirical one. For the given equation you can find it, but this is not your syllabus, this is beyond your syllabus. This is at microscopic approach. This is microscopic approach. This is nearly a microscopic approach. Okay, so that's why I told you no need to remember this Z. Just you need to remember what is sigma AB. This is cross section of collision. Cross section of collision, and how you are going to calculate? Very easy formula, pi dAB square, where dAB is the arithmetic mean of diameter of A and B. Okay. So please everyone tell me, is it crystal clear? Can we proceed? So the only thing that is very important for you is this T, temperature. Okay, now one more thing left, that is rho. Very good beta, crystal clear then. It's great, it's great. Now what is this rho? This rho is beta steric factor. Steric factor. And I am giving here the simplest explanation for it. Steric factor can be written as K experiment, what reaction rate constant you got with the help of experiments, and what is the reaction rate constant that you are getting from collision theory. That's it. This is here your steric factor. This is here your steric factor. Simplest explanation that you need to remember. Okay, now the main thing that you need to remember, if you are going to see in steric factor and overall things that you are going to see, then this Z is going to provide you one extra temperature term. That means now K from previous equation you can write as root of T into e raised to power minus e a by RT, or you can say K is proportional to t raised to power half e raised to power minus ea by rt. Now, can you tell me, beta, in this equation, who is going to strongly affect graph when you are going to plot graph? That is a k variation with temperature. Please listen carefully, beta. K variation with temperature. So exponential term or pre-exponential term t raised to power half. इन हिंदी, इफ यू वांट टू फील बेटर, इन दोनों में से कौन ज्यादा आपके ग्राफ को स्ट्रांगली अफेक्ट करेगा, मतलब ग्राफ में प्रीडोमिनेंट कौन होगा इन योर ग्राफ, विच वन इज प्रीडोमिनेंट वन? इज इट प्री एक्सपोनेंशियल फैक्टर टर्म टी हाफ, और is it exponential term e raised to power minus e by rt? Please everyone tell me, beta. Come on, please. If you don't know, then you can write r in comment section, but don't take too much time. Don't take too much time. Okay. So Shiva Tarun's pre-exponential factor term, that is T half. T half is not completely pre-exponential factor. This is one part of pre-exponential factor. Shusunandi don't know, Ayush don't know. My dear students, the pre-exponential factor, and if you're going to compare the exponential term, but you are absolutely wrong. Exponential terms are too much temperature sensitive here in comparison to that pre-exponential term. That's why when you will see transition state theory again, in transition state theory again one temperature term is there, but still the all theories no need to draw separate graph. The things will remain same, nearly same as you had seen in the case of Arrhenius plot. जैसा आपने Arrhenius plot में देखा है ना, just like Arrhenius plot that you had seen, the things will remain nearly same because the exponential term is more temperature sensitive. If you want to write, you can write here. You can write here. Out of these two terms, this is very very important things बेटा, बहुत ही डेप्थ में आपको बता रहे हैं, in depth. So this is more temperature sensitive, more temperature sensitive term in this equation, and this is less temperature sensitive term, less temperature sensitive term. You can also see by changing values. Okay, so you will see that the first term is not going to affect it too much. Okay, so this is the equation that you need to remember for collision theory, beta. And now how they are going to ask numericals, no need to worry, just now mathematical modeling is there, simple mathematical things are there. Like the equation number one, I can write like k is equals to some constant k naught dash into t raised to power half into e raised to power minus e a by rt. Okay, and now if this is your equation number two, so by equation 2 I can write by equation 2 for at temperature T1 I am assuming that K is K1 when T is T1, and when temperature is changes towards T2, then reaction rate constant changes to K2. Okay, so you will get two equations, similar manner, just very very easy. These things are very very easy. आप तो ये खुद भी कर सकते हो अगर हम छोड़ दें यार, कुछ ऐसा है ही नहीं, just it is same to same as you had done in Arrhenius. So here you will get simply k1, these all k's are small one, and k1 and k naught dash t1 half and e सॉरी अभी इसको मत करो, थोड़ा सा इसको और सिंप्लीफाई कर लिया जाए. दिस इज नॉट इक्वेशन नंबर 2, वेट. Now if you are going to take logarithmic just as you had taken in previous case, so it will come ln of k, that equals to ln of k naught dash and plus ln of t half minus E A by RT. Write this as equation number 2 beta. Okay, देख लो कुछ गलत तो नहीं हो रहा ना, नहीं है, everything is correct. Now you can write, you will get two different equations for two different cases. One is ln of k1, that becomes equals to ln of k naught dash. Now this is one more assumption we are going to take here, that this k naught dash is also not a function of temperature, just as you had seen in the case of RNS, as well as for activation energies. We are still assuming for these all theories that it is not going to become a temperature function. Okay, so it will remain same, k naught dash for both temperatures, and a plus ln of t1 raised to power half minus e a by r t1. Similarly, beta, for second case, you can write ln of k2, and that becomes equals to ln of k naught dash plus ln of t2 raised to power half, and minus ea upon rt1. The same thing, the same method. Now, if this is equation number 3, this is your equation number 4. So just you can again write equation 4 minus equation 3 here. Equation 4 minus equation 3. Okay, what will we get? वेरी हैप्पी गुड इवनिंग बेटा श्यान मुखर्जी, बहुत लेट आए बेटा आप, हाँ वाई? सो लॉन ऑफ के टू माइनस लॉन ऑफ के वन, दैट बिकम्स इक्वल्स टू लॉन ऑफ के नॉट माइनस लॉन ऑफ के नॉट कैंसल्ड, एंड हियर यू कैन राइट लॉन ऑफ टी टू रेज टू पावर हाफ माइनस ln of t1 raised to power half, and minus e a by rt1 this term, and you are subtracting this one now, so minus minus will make it positive, plus ea upon rt1 rt2. No, this is rt1, this is rt2. Okay, okay beta, now just focus here. Again you can write it as ln of k2 minus ln of k1, you can write like ln of k2 by k1. ये क्या भाई कमेंट्स गायब हो गए, वेट, ओके डन, ln of k2 by k1, and that becomes equals to, here beta you can write ln of t2 by t1. So t2 half t1 half, that means you can write ln of t2 by t1 and whole raised to power half, and if you are taking here common, plus ea by r, so plus e a by r, so inside bracket 1 by t1 minus 1 by t2, 1 by t1 minus 1 by t2. Please everyone tell me beta, is it same that you got? क्या यही इक्वेशन आपने प्राप्त किया आफ्टर सॉल्विंग? प्लीज टेल मी बेटा एवरीवन, is it same to same? Yes sir, okay, very good. So my dear student, this equation you have to use in order to solve numericals relating transition, sorry, collision theory. One equation, that means in your examination any one thing is unknown, like maybe they are going to give you t1 t2 k1, like see, universal numericals, universal numericals. Okay, like number one, they can give k1 given, k2 given, these terms are given, k1 given, k2 given, and t1 also given, t2 also given, and they are asking unknown, unknown activation energy according to collision theory. One equation, one unknown, very very easy. Or they can ask you, they can give you k1, they can give you t1, they can give you t2, they can give you ea, and now they are asking about k2. Number 3, they are giving t1, they are giving t2, they are giving ea, and now they are asking just ratios k2 by k1. Or they can ask you the ratios t1 by t2, or they can ask ratios like ra2 by ra1. because my dear student, this equation again you can write in similar manner that you had written in the previous cases. So it can also be written as equals to ln of minus RA2 upon RA1, or it can be written as, because rate is inversely proportional to time, so here you can also write it as ln of T1 by ln of T2. And based upon this, you had already solved one beautiful numerical yesterday. This is complete equation that you need to remember. Okay, beta. So how fast you can recall during examination? So 2 1, so here also 2 by 1 and raised to power half, but this is logarithmic term is also there. So don't be in hurry in examination. If required, just derive there. Derivation will hardly take a few seconds. Okay, just if you are writing first one, automatically you will get what will be derivation here. Okay, beta. So please tell me everyone, is it crystal clear to all of you? Can we proceed, beta? Can we proceed, my dear students? No doubts? All clear? Okay, so this is mathematical dealing. This is mathematical dealing. Okay, suppose they are writing in your examination like this. Suppose I'm one question I'm asking. One question I'm asking that k is equals to or k is proportional to t raised to power m e raised to power minus ea by rt. So my dear student, m value of m is, in your answer they can ask you the values of m, like value of m is 0 when it is following Arrhenius. Value of m is 1 by 2 when it is following collision. Okay, so I hope these type of easy question already asked in lots of PYQs. More than one PYQs are there in examination, you can find. Okay, so the value of m for collision theory is 1 by 2. For Arrhenius it is 0. Okay, now a few more thing I want to discuss. See, RCS, QE, and the third one, it doesn't agree more closely with experiments. Okay, so this one is first. See, beta, it is totally based upon kinetic theory of gases, and when you are going to get the values with the help of experiments, the values are not same, and in many cases errors are there. So that's why it is written here. It is doesn't agree more closely with experimental values. That's why the next theory that you are going to write, transition state theory, that theory, this time we are assuming that out of these two, more accurate than this collision theory, the transition state theory, because that agrees more closely with experiments. One point is written by me there. See, in collision transition theory agrees more closely with experiments. Who? This transition state transition state theory. Okay, now uh, one small heading I want to write here, that is simple. Please write this heading, beta. Small heading, subheading. Uh, Details of activated complex on graph with the help of one real example. Okay, I'm giving one real example. Just feel it. Just feel it. Then I will tell you a few things about collision as well as in that next theory, transition state theory. Most important, beta. Okay, most important. So in your graph, you had already seen this is what? This is your reactant. This is your reactant. Okay, and reactants now going to take their respective activation energy, and now they are going to form activated complex, and after that they are going to convert it into products. So in this graph, y-axis is energy, x-axis is reaction coordinate. So the same graph that you are going to make here, and the example that I am taking here, the reaction of hydrogen atom with ethane C2H6 in order to give hydrogen plus C2H5 radical. C2H5. C2H6 is also known as ethyl hydrogen. You can say C2H5H. Okay. See here. Methyl hydrogen. Now see. Here we have CH3, CH3, that is C2H6 beta. Suppose this is general basic molecular structure. Okay. And one hydrogen atom is also there. So what is here? These are reactants. These are reactants. Initially आप क्या ले लिए हो this side? These are reactants. These are reactants. Now what is going to happen here? They are now going to come together. Reactants going to come together. How? See, if this is your CS3 and this is your that hydrogen atom. So what is happening here? You can write here what is happening here. Reactants come together. Reactants come together. Now CH bonds distorts when they are coming together. CH bonds distorts. Okay. Now what is going to happen again? So here this is your simple C2H6 and hydrogen atom. Now here what is happening? Incoming hydrogen. Here incoming hydrogen pushes CH bond of the C2H6. अब इसको पुश कर रहा है. Okay, why it is pushing it? Because this C2H6 and this H now pushing that H from that C2H6 and now it wants to combine with that H. So जब ये पुश करता है ना, अभी पुश करते हुए आपस में एनर्जी लिया हुआ है, that energy required for that pushing in order to break that previous bond and in order to make that new bond. So that intermediate form, my dear students, that intermediate form, that is known as activated complex, because it is not a stable condition. It is pushing. After some time, pushes. If pushes completed, then now you are now going to get your product. Like here, what is going to happen? What is going to happen here, my dear students? Here now hydrogen moves out of hydrogen moves out of CH bond and into EH bond. अब जो आपका CH बॉन्ड के रूप में था वो हाइड्रोजन, अब वो H के साथ HH बॉन्ड में आ गया, दैट इज H2 आपको प्राप्त हो गया. ओके, सो नाउ फाइनली you are going to get your products here. Products. Now you are going to get your products. Inside your product, what is present now? This time this is what? This is CH3, CH2, and what is this? This is your H2. Okay. So in this figure, you had seen that how the hydrogen molecule moves into CH3 molecule. How that hydrogen atom converted into hydrogen molecule. Okay, so how it is going to move that CH3 molecule, distorting the CH bond and pushing the CH bond of the methyl hydrogen to arrive at the transition state. Okay, so is it crystal clear to all of you, beta? So here, this term, if you want to write, this is known as activated complex. यही क्या है बेटा? This is activated complex. This is activated complex. मतलब वहाँ कुछ वर्क हो रहा है. Highly energy is also there. High energy activated complex. After taking that activation energy, if someone asks you why there is a need of activation energy, just write here. One more point you can write here. Beta. Why is there? Why is there is an activation energy? अगर कोई आपसे पूछता है is an activation energy, so many theories are there, many explanations are there, so I'm giving you widely used answer here. So you can write two reasons here, beta. Two reasons. So number one, simple reason: the molecules need energy. The molecules need energy to distort, or you can say in simple language, to stretch, or you can say distort their bonds, their bonds, so that they break and now can form new bonds. Okay. Steric factor क्या है सर? समझे बेटा? Steric factor is simply the relationship of K. That is K, what K you are going to get with the help of experiments, and what K you are going to get with the help of collision theory. That's it about it. इससे ज़्यादा आपके सिलेबस में नहीं है. No need to go in more depth for this steric factor. Okay, बेटा सियान? That will be a statistical approach now. So इसलिए statistics आपको नहीं पढ़नी है. वो molecular level पे आपको नहीं जाना. You are not going to do PhD or experiments. Okay. So macroscopic, just you have to see macroscopic things. That is your syllabus, macroscopic. Okay, crystal clear, sir. Very good. So the molecules need energy to stretch or distort their bonds so that they break and now can form new bonds. In Hindi, if you want to feel better, so बस क्या है, molecules को नया bond बनाना है, तो पुराने bond को तोड़ना है, तो पहले ढकेलेगा, वो ढकेल के वो एटम जाके उसको ढकेल रहा है, वो एनर्जी एडिशनल चाहिए होती है, वही कहलाती है एक्टिवेशन एनर्जी. जो एक्स्ट्रा एनर्जी चाहिए होती है, पहले से एनर्जी तो थी बट वो नहीं कर पाए थे. पहले से कैसी एनर्जी थी भाई? भाई उनका बॉन्ड बना है, सो सम बॉन्ड एनर्जी एंड मेनी टाइप्स ऑफ एनर्जी इज स्टिल देयर ना यार. So that what extra amount energy required, that is your activation energy. Okay. So second one, similarly you can write that in order to overcome that electron repulsive forces, in simple language just write energy need to overcome energy need to overcome electron repulsive forces, electron repulsive forces, so that they come close together. Only if you are going to provide that energy, then in that case they are going to able to close together. Okay, so this one is crystal clear to all of you. No need to remember the same example. Just I want to give you feeling about activated complex कि क्या है activated complex. In Hindi, if you want to अगेन एक्सप्लेनेशन बेटा, तो यहाँ क्या हो रहा था, हाइड्रोजन एटम था वो CH3 पे जाके अटैक कर रहा था। हाइड्रोजन एटम ने CH बॉन्ड जो CH3 के अंदर बना हुआ था उसको ढकेलना शुरू किया, और जब वो ढकेल रहा था वहां जाके उसके साथ अटैच होना चाह रहा था, उस समय ही जो बन के तैयार हुआ वो था आपका एक्टिवेटेड कॉम्प्लेक्स। हाउ, सी हियर इन शॉर्ट इफ यू वांट टू राइट, सी दिस इज द डायग्राम, दिस इज योर A, दिस इज योर B, और यू कैन राइट दिस इज, रुको ऐसे नहीं, वेट, just write AB, just write as A, B and C. Now this is A, B, C. This is your activated complex. And now you are getting your product like A, C and B. This is your, suppose this is your product. Yeah, this is your product. ओके, सो सी ने बी को ढकेल के उसका प्लेस ले लिया, और जब ये ढकेल रहा था, जब ये सारा प्रोसेस चल रहा था, उस समय के ही फेज को, ना तो उस समय रिएक्टेंट्स अलग अलग थे, ना तो उस समय प्रोडक्ट बनके तैयार हुआ था, उस इंटरमीडिएट फेज को ही आप लोग एक्टिवेटेड कॉम्प्लेक्स कह रहे थे। व्हेन दिस प्रोसेस आर हैपनिंग, द ए बी सी आर नॉट आइदर, you can say like these are reactants or not product, nor product. So what is there, neither reactant nor product, so what is this, so this is activated complex, this is high energy activated complex is there, they are now going to decomposes into the products, this activated complex now going to decompose into the product. Okay beta, is it crystal clear to all of you? Is it crystal clear my dear students? Please tell me beta, क्या ये आप सभी को क्लियर है क्या? सभी को क्लियर है? प्लीज टेल मी, वेटिंग फॉर योर कमेंट्स बेटा, फटाफट सभी लोग बोलोगे, एवरीवन प्लीज टेल मी बेटा. Why I explain these things, why I need this example, because I want to show you slowest step, fastest step, and only you can feel it if you are seeing some real example. Yeah, so that's why I'm giving this real example, but no need to remember this real example, just take his feeling that what is activated complex. Okay, what is activated complex? Okay. हाँ सर लिख रहा हूँ, लिख लेना बेटा बाद में वापस से, अभी क्या वेट करें, क्या लिखोगे, क्या लिखे नहीं थे क्या अभी? You want more time to write it? You want more time to write it? Or can we proceed, beta? Please, everyone tell me. Can we proceed? Just write, everyone. 1 मिनट हो जाएगा, चलो भाई ले लो, but try to write along with lecture, beta. Okay? Just after writing, write done in comment section. Then I will change slide. No, beta, महना. Attraction जहां पे रिएक्शन होता है, the reaction is going to happen, वही तो रिएक्शन होगा ना. So the weak portion, only weak portion can be affected by the other one easily. That's why here hydrogen is going to push that CH bond, not CC bond. Okay, is it clear beta maina? And how, which one to which, who is going to push which atom, this is your chemistry gate syllabus. Chemistry, here just I had given this example because this example is present in standard books like Fogler. So with the help of this example you will be able to feel just what is activated complex. यार आपको केवल activated complex की feeling देने के लिए इसको हमने यहाँ पे लिखा. Done? Okay, चलो भाई आगे बढ़ते हैं. So my dear students, when you are talking about this collision theory, tell me, in this collision theory, which one is main step? That effective collision which is responsible to make activated complex, or the decomposition of activated complex, which one more focused, more concentrate, we concentrated inside this collision theory? Please everyone tell me beta, collision theory में आप ज्यादा फोकस्ड कहां थे, उस एक्टिवेटेड कॉम्प्लेक्स के बनने पर या एक्टिवेटेड कॉम्प्लेक्स के डिकम्पोज होके प्रोडक्ट देने पर? Which was step? Please tell me, everyone. Which step? Formation of activated complex. Very good. Because that step is the slowest step. As I told you, the effective collision is value is much less than, in many cases, much less than 1%. Yeah, effective collision percent is much less than 1%. That means that step is very slow. That step is very slow. That's why, my dear students, when you are writing that graph again here, when you're writing again here, so uh, this is the slow step and this is the fast step according to collision theory, not according to transition state theory. So in Arrhenius didn't told about which one is fast slow. According to Arrhenius, just immediately taken activation energy, converted into product. But according to collision theory, the formation of activated complex is slow from reactant from reactant to activated complex and then activated complex to product. So the step in which reactant going to convert it into activated complex, this is the slowest step, and the activated complex decomposition into product, this is fastest step. So what step is rate controlling step? Slowest step. समझ पा रहे हो बेटा? श्याम मुखर्जी, एक्टिवेटेड कॉम्प्लेक्स बनने पर फॉर्मेशन ऑफ एसी ब्रेकिंग ऑर्गेनोग्लोमेस जल्दी होता है सर? हाँ सर, वहां पर एजम्पशन वही था रीनियस थ्योरी में. ओके बेटा, बोलो ये क्लियर है कि नहीं? जस्ट टेल मी यस और नो. Just tell me yes or no. Is it crystal clear? So here, which step is rate controlling a step? In examination, they can ask you better this one. So inside collision theory, the formation of activated complexes, RCS means rate controlling step. हाँ सर, क्रिस्टल क्लियर. बहुत अच्छा, सभी को क्लियर बेटा? एवरीवन क्रिस्टल क्लियर? Everyone crystal clear beta? So this step is the slower step in case of collision theory. In case of collision theory, this is the slower step and this step is the faster step. Now if I'm asking beta, first beta, please tell me everyone, do you know anything about a quasi equilibrium? क्या इसके बारे में जानते हो? What is quasi equilibrium? What is quasi equilibrium? You will see again in subject thermodynamics. Please tell me, do you know anything about quasi equilibrium यार? इसके बारे में जानते हो क्या? सुना है सर. क्या होता है थोड़ा बता भी दो यार, अगर सुना है सर तो प्लीज टेल मी. क्या होता है बता दो भाई. एवरीवन प्लीज टेल मी. डोंट नो? ओके. Quasi equilibrium means that changes are very infinitely slow. Process happens in very good small step. Very good, Mr. Smith Nandi. Absolutely correct. बहुत अच्छा. In thermodynamic subject, you will see when this is a piston, okay, and above piston, suppose there are many small 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 toffees are there. And now if I am going to take that small toffee one by one, this piston will move up very slowly. Very slowly. That is quasi study process. Quasi study. So quasi means what beta? That the changes are very small. If changes are there, that changes is very small. That you are feeling that this is just like you can feel this is equilibrium, but that is not in reality. That's why it is known as quasi equilibrium. Clear? Chalo. Very good. So here what I want to ask about this quasi equilibrium. Just you had seen if this is your reactant, this is your activated complex, This is your product. So just I want to ask you here for collision theory. I'm asking for this collision theory for collision theory. The quasi equilibrium is going to form between R and AC or AC and P. Which one? Which one, beta? Quasi equilibrium between आर ए सी और ए सी एंड पी बताओ फटाक से बताओ एवरीवन प्लीज टेल मी जस्ट थिंक इट आई एम गिविंग यू 20 to 30 सेकेंड या आराम से सोच लो फिर बताओ जस्ट थिंक अबाउट इट देन टेल मी स्टिल वेटिंग फॉर योर कमेंट्स आर ए सी होगा सर बिकॉज इट इज स्लो स्टेप शियान मुखर्जी कियादास आर ए सी आर ए सी आर ए सी थिंक अबाउट इट और सोचो ए सी एडवर्ड कॉम्प्लेक्स और प्रोडक्ट पर होगा गूगल तो नहीं कर रहे हो ना जी क्योंकि आंसर पहले कुछ देते हो फिर बदल लेते हो हम्म बताओ भाई जल्दी जल्दी बोलो टेल मी Actually, I'm giving you 30 to 40 seconds. Think about it. ये तो स्लोवेस्ट स्टेप है पर ये तो क्लोज टू इक्विलिब्रियम में ही तो है ना सर पर क्वासी नहीं एक्चुअली बेटा इन रियलिटी there is no quasi equilibrium that you are going to see in collision theory. Collision theory में होता तो नहीं है. But when you are going to see that if someone is forcefully asked you that in a few books I had seen that line is written, so what you are going to give answer, why it is not there, क्यों नहीं होता है, उसका हम आपको रीजन बताते हैं. Wait, just see assumptions. Assumption number one, hard sphere molecules. You are assuming hard sphere molecules. That means they are going to hit each other. They are going to hit each other. But they are not going to make any activated complex at all. If they are going to hit in the properly oriented manner, immediately they are going to convert it into product. That's why I told you, if you are going to write this like two-step process, that this is the not fastest, very very far fastest process. मतलब इसमें इस थ्योरी ने कहा है, in this theory it is assumed that immediately if effective collision is there, then immediately they are going to convert it into products. बोलो समझ में आ रहा है कि नहीं आ रहा है? Are you getting my words? Please everyone tell me. Please everyone tell me. Sir, can you repeat? Beta, just see assumption. Just see beta assumption. Then I will explain again. Assumption को आराम से देखो बेटा सुष्मित दंडी. Then I will explain it again. Tell me beta in detailed manner. Assumption देख लिया sir? Okay, yes sir, assumption seen. Uh, Inside assumption, the first assumption is there are hard spheres. If you are going to see this line in more and more depth, hard sphere means what here? That immediately when effective collisions are going to happen, immediately they are going to convert it into product. There is no such activated complex that you are going to see there for very last time. Are you getting my words, beta? Yes, sir. So here, if you want to give that some quasi-equilibrium forcefully is there, so you are going to give quasi-equilibrium between AE and product. And you can also write here, not correct totally. According to this theory, it is not correct totally, but can be asked if asked in GATE. If asked in GATE PSU. Because एक ऐसा क्वेश्चन हमने देखा हुआ है, because you know in this field I have completed now nearby 15 years, and every year lots of PSU's papers are going to happen. So I had seen many questions from this topic. Yeah. जब भी आप पेपर दे के आते हो, then discussions are there. So this problem was asked few, I think 7 or 8 years ago. 7 or 8 years ago. So 7-8 साल पहले जब पूछा था, उस समय ही हमने इसको अपने नोट्स में इंक्लूड कर लिया था कि बच्चों को ये पढ़ा देंगे, बच्चों को भी बता देंगे कि अगर पूछता है, इफ दे आर गोइंग टू आस्क इन गेट एग्जामिनेशन इन एग्जामिनेशन, देन यू हैव टू राइट लाइक क्वासी किलोमीटर्स बिटवीन एसी एंड प्रोडक्ट हियर. activated complex and product here. Okay, done. That means as soon as activated complex formed, activated complex immediately going to convert it into product. You are not able to see that activated complex there. So every time the activated complex amount is very very less, that you are going to see there, and it is going to increase a small amount of that product after every small step. So that's why here the quasi equilibrium you can write that is between activated complex and product. Okay, बस अब याद कर लो इसे. And please tell me, can we proceed here? Can we proceed? Is it crystal clear to all of you? Crystal clear, sir. Okay, very good. Okay, so please write next theory. That is the transition state theory, TST. Transition state theory. But this theory is also known as activated complex theory. This is also known as theory of absolute reaction rate. This is also known as absolute rate theory. Okay, and this is also known as Eyring's theory. Eyring theory. So many names are there. Okay, and one problem already asked in examination, which one of the following theory is also known as activated complex theory? And the right answer is transition state theory. So these type of questions can be asked. Okay, now transition state theory, why it is also known as activated complex theory? Because it is more and more focused on activated complex. It is more and more focused on activated complex and its decomposition into product. Its decomposition into product. In short form, if you want to see better, again, if you are going to make that diagram, if this is your reactant, if this is your product, if this is your activated complex, now this time, according to this theory, this step is very very fast. That was reacted immediately going to convert it into activated complex. But the decomposition of activated complex, this is the slow step. Okay, सर साथ में लिखने में आदत हो जाएगा सर, थोड़ा धीरे चल रहा है सर, पहले दिमाग समझने में लगता है. Okay. Sir, क्या था? Sir, what is quasi-equilibrium? But a quasi-equilibrium, if you want to define, then if the change is very, very slow, if the changes is very, very slow, that is known as quasi-equilibrium. Okay? Is it clear, beta क्या दाश? Is it clear? Simply, you can describe a thermodynamic process that is so slow, very slow, so that the system remains essentially in equilibrium throughout. Okay? अगर आपका सिस्टम लगता है, आपको फील होता है कि लगभग लगभग ये इक्विलिब्रियम में ही है, बट एक्चुअल में होता नहीं है, इसलिए क्वासी शब्द वहां लगा दिया गया है, क्वासी इक्विलिब्रियम. ओके, so sir, in reality, which step is actually slow and which is fast? Beta, it is depend upon reaction to reaction. And if we can't neglect both theories and you are going to study both theories, that means in a few uh, reactions the first step may be slow, in few reactions second step may be slow. Okay, because the transition state theory is totally and totally based upon experiments यार. Okay, ये experiment के ऊपर में बेस है. समझ पा रहे हो बेटा? सुष्मित नैंडी. तो एक्चुअली में कौन सा स्लो है अगर हम बता देते तो एक और थ्योरी आ जाती. इफ आई एम एबल टू टेल यू, देन वन मोर थ्योरी इज देयर, गौर थ्योरी ऑफ temperature dependent term, Gaurav sir theories. Eh? Then you will see Gaurav sir had given this theory in 2025. Okay, बट हमने एक्सपेरिमेंट नहीं किया है, और डिटेल्ड मैनर में आई डोंट नो, और इवन बाकी लोग भी, साइंटिस्ट भी, डोंट नो अबाउट इट in actual what is going to happen, because the activation energy that you are going to calculate by these all theories, it is not going to match totally with experiments. ये totally आपका match कभी नहीं करेगा. Errors are every time, errors are there, errors are there. But why we need these theories? Suppose you are going to calculate the activation energy value. ओके, हम जस्ट एक पीएचडी का आपको बता रहे हैं. वन पेपर आई पढ़ा था हमने, वन पेपर रीड, पीएचडी पेपर. उसमें क्या था, आई एम टेलिंग यू. If you are going to calculate the activation energy based upon theories, suppose the activation value is coming 95, 95. But now when they are going to check in reaction with the help of experiment, collected data, now what they are getting, that no, 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 the activation energy value is different one. Based upon this, they had given one conclusion, that this reaction is not elementary one, this is some more complex reaction, some more intermediate steps are there, that's why it is not totally mismatched. But if it is nearby, like you are getting 100 with the help of equation, and by experiment if it is 95, 105, then you can say, yeah, this is elementary and this is its mechanism. So many things you are going to do, but that things you are not going to do in undergraduate. For that, only you can do in phds. Okay, so this time, that's why no need to explain more, or no need to give more time to this topic. Is it crystal clear, beta? Can we proceed? Just tell me, beta, can we proceed? So transition state theory, I-ring theory, I-ring theory, activated complex theory, theory of absolute rate theory. It is given by Henry Eyring in 1935. This year is not important, but this is important, that the oldest theory is Arrhenius. After that, which theory comes? Collision. Then latest theory is transition state. Sequence is important. Sequence is important. Okay. With significant contributions from M. Gwen Evans and Michael Polanyi. क्या लिखा हुआ है, नाम भी इनका खतरनाक होता है. ओके, सो Polanyi. Okay. So here the only the name that is important is H. Eyring. This name is important only. This name is important only. So this is your transition state theory. This is your transition state theory given by Henry Eyring. And the one thing that you just known about it, that the reactant to activated complex, this conversion is the fast one, but the decomposition of activated complex to product, this is the slowest step here. That's why it is known as transition state theory, because it is more and more focused on the transition of activated complex to product. Okay, and now you can easily tell me what is rate controlling step. Reactants and the transition state are in equilibrium here. Formation of activated complex here is very rapid, whereas its decomposition is slow. So tell me what a rate controlling step. Reactant to that activated complex और activated complex to product, इसमें से rate controlling step कौन सा है? Which one is rate controlling step here? Tell me everyone. Activated complex to product. बहुत अच्छे बेटा, very good, fantastic. So it is activated complex to product. This is your rate controlling step here, because this is slowest step. This is the slow, whereas decomposition is slow. So decomposition of activated complex to product. Decomposition of activated complex to product. This is the rate controlling step here. It is agrees more closely with experiments, or how you are saying this. I am not saying this. It is written in books by these our researchers. So they got that it is more closely agrees with experiments. So you are also going to write it is more closely agrees with experiments. Okay, that means the value that you are going to get with the help of this theory. That means the limitation of previous theory, that is basically based, or you can able to calculate the things only for gaseous reactions more accurately. Here that limitation is not present. Now you can also apply it for liquid side. That Doesn't mean that in your examination, if they are asking for liquid and they're asking that collision theory is there, so you are not going to calculate it. You have to calculate according to given data. Okay, आपको given data के according calculate करना होगा. So if some theory is accurate in something, some theory is accurate in something, that's why lots of theories are there. अगर कोई एक, if only one theory is totally accurate, then in your books just you are able to see that one single theory. आपको केवल वो एक सिंगल थ्योरी ही पढ़नी पड़ती है, अगर हर एक केस में वही आपको सही वैल्यू देता. बट व्हेन यू आर गोइंग टू डू रिसर्च वर्क्स, द थिंग्स दैट यू आर गोइंग टू कैलकुलेट विथ मेनी मेनी थ्योरीज, एंड देन यू आर गोइंग टू कंपेयर विथ योर एक्सपेरिमेंट्स, एंड देन यू विल गेट सम कंक्लूजन देयर. Okay. So here the main assumptions that can be asked in examination. Many assumptions are there for all these cases. That assumptions are like a microscopic level assumptions. So the main assumptions that macroscopic type that that can be asked in gate examination. Just two here. That one is quasi equilibrium. So just you had seen quasi equilibrium is between reactants and activated complex. Here, the quasi-equilibrium is in reactants, and the transition state means what? Activated complex. Just you can say opposite of that collision theory. So very, very easy to remember. Just remember the fastest step that you are seeing. That is going to give you that quasi-equilibrium. That means immediately that just reactant is there, immediately converted into activated complex. So there is a equilibrium there. That reactant आ रहा है धीरे धीरे फटाक से वो convert हो जा रहा है वहाँ पे. And the next step is the slow one. So what is the second assumption here? That is barrier crossing. ये क्या है यार? And don't try to just compare with your thermodynamic quasi-equilibrium here. Okay, that's our quasi-equilibrium there, because the meaning of every word is dependent upon the topic. तो यहाँ जो टॉपिक है उसके अकॉर्डिंग कॉसी इक्विलिब्रियम रिएक्टेंट्स के रूप में डिफाइन किया जा रहा है कि जो चेंजेस आ रहे हैं किस तरह के आ रहे हैं. ओके, आर यू एबल टू अंडरस्टैंड? समझ पा रहे हो कि हमने क्या बताया अभी? Are you able to understand, beta? Reactants are in equilibrium. Reactants are in equilibrium with transition state in case of transition state theory. This is the core assumption of transition state theory. ये हमने कहा बेटा. दिव्यांश. क्लियर बेटा? बहुत सारे इसके रीजन है. हाउ इट इज इन इक्विलिब्रियम आई डिडंट अंडरस्टैंड सर मेहना. बेटा देखो, सी, if you are going to see reactant and P, इसको बहुत ज़्यादा एक्सप्लेन कर दें क्या पूरा लिख के? बट दैट इज़ नॉट रिक्वायर्ड हियर यार. रिक्वायरमेंट है नहीं. चलो देखो यहाँ क्या कह रहे हैं आपसे. आई थिंक वेट, सी, सपोज बेटा दिस इज योर रिएक्टेंट ए. ओके, दिस इज योर रिएक्टेंट ए. रिएक्टेंट अभी क्लियर हो जाएगा. वेरी वेरी क्लियर. क्यों हम कह रहे हैं? इन ईजिएस्ट मैनर. आफ्टर दिस द डार्कनेस विल बी 0%. It's my promise to you, because immediately one beautiful example come in my mind. Barrier crossing, इसके आधार पे आपको बता रहे हैं. This A is going to converted into transition state. What is transition state beta? This is your activated complex. Activated complex. Okay. Now this activated complex TS is going to converted into product. अभी देखो क्लियर हो जाएगा मस्त तरीके से. आप लोग क्या कर रहे थे ना, यू थिंक पिस्टन सिलेंडर, आप पिस्टन सिलेंडर के रूप में सोचने की कोशिश कर रहे थे, यू आर थिंकिंग इन द फॉर्म ऑफ पिस्टन सिलेंडर क्वासी इक्विलिब्रियम। नो नो, दिस इज रिएक्शन बेटा, दिस इज रिएक्शन क्वासी इक्विलिब्रियम. So my dear student, this is step number one here that you are seeing here, but this is fast one and this is reversible one and this is slow and irreversible one. Now tell me beta, equilibrium that you are going to obtain for reversible step or irreversible step, अब बता दो यार, अब तो मत पूछना यार कि सर अब समझ में नहीं आया, प्लीज टेल मी नाउ सर, 100% crystal clear. So here quasi equilibrium is going to happen because the step number one is reversible one. Is it crystal clear beta? Is it crystal clear? Please tell me everyone. Can we proceed my dear students? What is barrier crossing? Once the system crosses the transition state towards products, it doesn't return. See, barrier crossing. Once crosses the barrier and this once converted into product never again come to A. This is the barrier crossing assumption number two. Everyone, please tell me, is it crystal clear? What is quasi equilibrium? In what context I am telling this? Equilibrium, quasi equilibrium. फटाफट बता दो बेटा, क्या ये क्लियर है आपको? Is it crystal clear to all of you? Is it crystal clear, my dear students? Can we proceed? So what is barrier crossing means? What is the meaning of barrier crossing means? Once the system crosses the transition state towards product, it doesn't return. एक बार आपका सिस्टम ने क्रॉस कर लिया ट्रांजिशन स्टेट को, प्रोडक्ट की तरफ चला गया, तो वो वापस नहीं आएगा. यही आपका सेकेंड एजम्पशन है. And this assumption well explained about the assumption number one, quasi equilibrium. Clear? What is the limitation? That is barrier recrossing. Here you are assuming no return after crossing TS. Sometimes it is going to estimate, overestimate rates. That means the rate is 20 and it is going to estimate like 40, because in reality, they can again come. They can again come in reality in most of the cases. Okay, but because if reversible reaction is there, then how you can say that it is not going in that again towards that reactant if reversible reaction is there. So the value that you are going to calculate with the help of this theory is definitely is going to fail, because it is telling it didn't return, but in reversible it is going to return, it can return. Okay beta, is it crystal clear? सभी लोग लिखेंगे, please everyone tell me one more time. I am giving a full depth of these theories, but mostly you can see in most of the places, all these theories they are going to give in just one lecture, No assumptions, no limitations, nothing they are going to explain. That's why when you are going to face BARC interviews or any NPCIL and a higher type of interviews, and when they are going to start asking, you can feel, oh, I have just equations that t raised to half t and t raised to power 0. That's not complete thing. But I hope beta, the depth that I am giving here, everyone now able to understand completely. So if yes, then one more time please write crystal clear so that we can move forward. Come on everyone, please tell me beta, come on, jaldi jaldi likha karo, please tell me everyone. Is it crystal clear to all of you beta? Sabhi log, if 0% darkness, then only say sir crystal clear, then I will move forward. Come on everyone. पानी लेके आए थे यार, पानी ही पता नहीं कहाँ रख दिए हम यार. Thirsty, I am thirsty. Shiva Tarun done, sir. Devarsh Agnihotri done. Shusmit Nandi, Ayush. Other students, I want comment from each and every student. Can we proceed? Can we proceed, my dear students? That's why I told you the quasi theorem is mainly it is not available in that collision theory, because no such type of cases are available in collision theory. Okay, but if in examination they are asking forcefully, see, I had written inside bracket. Okay, I had written inside bracket. Forcefully, if they are asking, then you have to write ACN product. Otherwise, no need to write. Okay, done. Okay, sir. Crystal clear, sir. Yes, beta. Please ask, sir. One more doubt is there. Please ask me, beta. Ask me your doubt. Reversible reactions are slow usually. बेटा ऐसा नहीं है. The net reaction rate होता है जो towards reactant to product, that you can say slow. That you can say slow. Okay. Net conversion, because reactant is going to convert into product and product same time going to convert into reactant. But maybe you are going to compare this with some irreversible reaction whose activation energy value is much higher in comparison to this reaction. Then you can't say, that this is a slower one, this is your slower one. Okay, is it crystal better में ना? आप ऐसा कह सकते हो रिवर्सिबल में जो एंड होता है एंड स्टेट, दैट इज नॉट गोइंग टू गिव यू 100% कन्वर्जन. That's why in reversible reaction you are focused on XE, that is equilibrium conversion. That is equilibrium max conversion that you can obtain. Okay. Thank you sir. You are welcome beta. Okay sir. श्यान मुखर्जी. Okay beta. So crystal clear. Can we proceed? फटाफट बता दो यार. आगे बढ़ जाएंगे हम लोग. So theoretical part everyone able to feel it. सभी को feel हो गया. Can we proceed? Okay. So all clear then. Great. So now mathematical things, very easy. So please write according to transition state theory. According to transition state theory, K this time is beta proportional to T E raised to power EA by RT. EA by RT. And further you can write like K is equals to K naught double dash T E raised to power minus EA by RT. Further, the equation number 1 that written by me beta, it can be asked in your examination and asked many times in many examination. That according to transition state theory, please tell me. According to transition state theory, please tell me. So according to this theory, you can see. Now, mathematical things are very easy. Just in similar manner, take again log. So you can write ln of k, that equals to ln of k naught double dash plus ln of t and minus EA by RT. So please again derive it. Don't see on this slide. Please derive it independently and then just compare with my answer beta. Just compare with my answer. Okay. So here I'm not going to write that. Just derive it. If you are also getting the same to same answer, then write yes sir. Just do step by step. Don't write it directly from slide. Just do this step by step. Say step by step करेंगे and then just compare with me that you are also getting the same or not. Got it beta? Yes, so just write done in comment section. Just write done in comment section. Done. Very good. So let's start solving few numericals. See beta numerical number 44, 45, 46. Please solve this and tell me answer. Solve all three parts and give me answer, all answers just in a single comment. Last 3 minutes, beta. To the nearest integer though, because value is very very large. All answers just in one comment, beta. Ayush, by using comma. Timer restarted. Resumed. But your answer is not correct. Ayush, please calculate it again. If you are still doing silly mistake, so beta please don't forget to convert temperature into Kelvin. Okay, Sati, that means you had done same mistake, huh? Time up here. Not a single answer come. Okay. Timer refreshed. Okay, so one answer coming from Susmit Nandi. Beta, your answer is not correct, I think. Your answer is not correct, beta. All answers are wrong. Shiva Tarun. 8262. Okay. 81413. Congratulations, Shiva Tarun. Your answers are absolutely correct. All three answers correct. So only one answer I got. Tell me what everyone. Very good, beta mehna. Tell me, beta, come on. सॉरी सर टेम्परेचर 303 की जगह 293 ले लिया क्यों बेटा इट इज 30 डिग्री सेल्सियस ना सो प्लीज राइट डाउन दिस इन योर सिली मिस्टेक डायरी so that next time you are able to extract correct data. Calculate it again beta. Okay, done. Come on. Now you can see all three answers are nearby. That's why I told you na. The exponential term is more temperature sensitive. See, one more temperature term is there, but the answers, the values are not changes appreciably. ये समझ में आया? Please write yes in comment section. Crystal clear, sir. One more time, beta. The theory that I told you earlier. Now see, also same theory here proved with the help of this numerical. Is it clear to all of you? Very good, beta Ayush. Okay, you are also in the range. Okay, so timer resumed again, and now final 1 minute. Very good. So many answers now come. Susmit, Ayush, Mehna, Shiva, Tarun. This time, Susmit, your answer is correct, beta. Very good. Don't do this silly mistake again, yaar. Okay? Don't do this silly mistake again, beta. Shan Mukherjee, you didn't get answer, beta. Kiadas, very good, beta. But beta, Kiadas, your second and third answer is not correct, beta. Yes, sir, we'll never do it again. Okay, beta. Very good, Sushmit Nandi. And don't forget to write in your silly mistake diary. एक सभी लोग बना लो. Please make a silly mistake diary. There just you have to write that you the mistakes that you are done. If you are feeling that it is silly one, then just write it. Like extracting data from question. This is a silly mistake done by you. So just write there so that in future you are not going to repeat this mistake. क्या दास बेटा second third answer didn't match. So please try again. You had done some mistake there. कुछ तो mistake किया है बेटा because if you are doing mistake in calculation, that is totally unacceptable yeah, in examination. If you don't know concept or how to solve that numerical and you are going to left in examination, that's okay. But if you know and still you are doing mistake, that's not good. In that case, never you are going to get a good rank. But don't worry, still you are in June month, July, August, September, October, November. Still you have 6 7 months left. So please overcome this silly mistake. Check twice, but sir, I am getting. Okay, beta. Ayush, answer is correct. Your answer is correct, beta. 82630 is correct. Kia Das, your answer is not good. Right, beta. Okay. No problem. Still, you are in the range, beta, Ayush. Okay, you are not getting 82630. Maybe, beta, you are using something different R value like up to 3 decimal place or up to 4 decimal place or up to 5 decimal places. Or maybe you are doing in two-step calculation, not in one-step calculation. Don't worry, still you are in the range. Okay, because if they are asking in examination, they will ask in kilojoule per mole, and in that case the answer will be ranged 82.6. So they will give range from 82 to 83 at least. Yeah. कर सर मेरा मैसेज देखा ना सर यू आई हैड सीन जस्ट वन मैसेज फ्रॉम योर साइड बेटा नो टू मैसेज फर्स्ट इज नॉट करेक्ट 73315 इज नॉट करेक्ट बेटा प्लीज डू इट अगेन आंसर नंबर 45 for collision theory your answer is not correct. Do it again you had done some silly mistake. So देखो बेटा कैलकुलेशन मिस्टेक मत करो यार प्लीज डोंट डू दिस मिस्टेक यार again after this lecture you have to do this calculation. Okay, if unable to get in just one attempt during this live class. So here first you are going to extract data. Now just focus on my approach. The rate constant of a certain reactions are k1 is equals to 1.6 into 10 raised to power minus 3 second inverse. Can you tell me what this reaction is first order reaction or second order reaction or third order or zero order or some fractional order? And 1.625 first order. Very good, very good. I think few students are doing mistake in seeing this 10 raised to power minus 2 in hurry. I think you are writing this also 10 raised to power minus 3. ऐसा किया क्या क्या? Any one of you had done this one? Then please tell me. अगर ऐसा किए हो तो please tell me. Now T1 is 10 degree Celsius, 30 degree Celsius respectively. Any one of you had done the same thing? This silly mistake done by you? Yes or no? So this is 283 Kelvin and 273 plus 30, this will be 303 Kelvin. So data is completed. Now you need the value of R because joule per mole you want. So R taken 8.314 joule per mole per Kelvin. If they are asking in 2026, so mostly chances are there that they are also going to provide the value of R for better accuracy. If you are not going to provide the value of R, then the range will be little bit wider one. So don't worry. In examination, you can take 8.31451 complete range. You can complete up to 5 decimal place you can take in examination. Okay. So now by Arrhenius theory, first one, 44 number, Arrhenius theory, Arrhenius theory, see on the same page, 45, collision theory, then 46, transition state theory. Okay, so based upon Arrhenius, the equation was ln of k2 by k1, that becomes equals to ea by r. ea is there? No, ea was asked. Okay, ea by r, 1 by t1 minus 1 by t2. Now for collision theory, ln of k2 by k1, see how I remember. It's t raised to power half, so ln of t2 by t1 raised to power half. In similar manner that you had written k2 by k1, so here t2 by t1. Okay, and here plus, don't use minus in examination. Okay, here plus ea by r, and now k2 by k1, so first use t1 and then use t2. This is the way to remember. Here ln of k2 by k1, and that becomes equals to ln of, that's just t raised to power 1, so you can write t2 by t1 and plus ea by r 1 by T1 minus 1 by T2. Now just you have to put values, you will get your answer. Nothing special here. So here ln of, what is the value of K2? K2 is 1.625. So 1.625 into 10 raised to power minus 2 and सॉरी उल्टा लिख दिया क्या हमने 1.625 into 10 raised to power minus 2 and the value of K1 is 1.6 into 10 raised to power minus 3 is equals to EA upon 8.314 and now temperature was T1 was 283 303 283 303. Okay, so one equation, my dear students, one unknown. After solving you will get EA कितना आया था nearly 82630 82630 nearly. The unit will be joule per mole. This is the answer number 1. Very, very easy. Similarly, you have to put the values in the second one. So in second one, it's ln of, again same thing, so no need to kill time here. You had already done. So just put values here again, K2, K1, all things. Again, you can see just one equation, one unknown here. So after solving, it will give you EA nearly 81493. फर्स्ट आंसर किसका था जो हमने मिलाया था? शिवा तरुण, 81413. It will come nearly 81413 joule per mole. And the third one, after calculation, it will come 80196. 80196 joule per mole. EA equals to. बोलो बेटा, सभी को क्रिस्टल क्लियर? कैन वी प्रोसीड? Is it crystal clear to all of you, my dear students? Can we proceed? जी सर ये मिस्टेक्स देखूंगा. ओके बेटा, डोंट डू मिस्टेक्स. These are very, very easy calculations. So if you are doing mistake, then at least practice minimum 10 times. When you are getting 10 times same to same answer, then stop calculation. 10 बार कैलकुलेशन करोगे सेम आंसर आएगा, तब समझ लेना कि अब ये मिस्टेक दोबारा एग्जाम में नहीं करोगे. अदरवाइज यू नो एवरीथिंग एंड स्टिल नेबल टू गेट रैंक. यार द मोस्ट हैपेंड थिंग विद मोस्ट ऑफ द स्टूडेंट्स, बहुत सारा बच्चा होता है आफ्टर एग्जामिनेशन व्हेन कम एट होम, ओ आई कैन टेक 20 मोर मार्क्स यार, आई कैन गेट 15 प्लस मार्क्स एट लीस्ट यार. सो इफ यू आर गोइंग टू just completely remove your silly mistakes, better definitely you are going to get good rank. Okay, because now you are getting here best content of India, openly challenged best content of India. So if best content, so only one thing that can stop you to get good rank. What is this? That is your silly mistake. So if you are going to remove your silly mistake, beta, no one is going to stop you to get good rank. Okay, so now next question, see beta, question number 47. Now just focus here beta, be focused Shan Mukherjee. Now see problem number 47. This time I want answer again within given time. So just I am going to start timer. Timer start करने चाह रहे हैं just after few seconds. Just you have to tell how much faster means how much times of initial one. How much times of initial one. Okay. So timer started. Last 3 seconds is still not getting any answer. Your calculation is little bit slow, beta. Okay, try to increase speed of calculation because nothing is special here. All things are given. Just one equation, one unknown. And my dear students, if nothing mentioned in any question, which theory you are going to apply, you all know. So here, nothing mentioned. Okay. Susmit Nandi 1978.31. Mehna 1970.7. Ayush 1960. This is decreasing order. Answers coming in decreasing order. Now, same answer as Mehna by Shyan Mukherjee 1970.7. Shiva Tarun is 1970.7. Very good. Now, Zerom also getting same answer 1970.71. That means Sushmit Nandi and Ayush, you both are doing some approximations during calculation or you are doing in more than one step. Okay. Yeah, but answer is same. Answer is same. 1970. Nearly. 1970 times. Sushmit Nandi, yes sir, I did it in two steps. So beta try to do by using virtual calc in just one step. एक step में करने की कोशिश करोगे इसे. Okay. If you're still unable to do, ask me. I will tell you. लाइव क्लास में आपको दिखा देंगे कैसे कैसे कौन से प्लेस से यू हैव टू स्टार्ट फ्रॉम विच प्लेस योर कैलकुलेशन सो दैट यू आर एबल टू डू कंप्लीट कैलकुलेशन इन जस्ट वन स्टेप. Don't try to use that recall option or remember option of your calci that can do some silly mistakes in examination. So just avoid that function of your calculator. उस function को I am not going to recommend you. Okay, हम recommend नहीं करते उसे. Okay, now just focus here. Problem is very very easy. So the pyrolysis of reactant A proceed with an activation energy is about. Now here the silly mistake number one that you can do. It is in kilojoule per mole. So don't be in hurry in examination and don't be overconfident that if you are not doing mistake here in this class, so in examination you are not also not going to do mistake. So be careful. Okay, it is 300,000 joule per mole. So temperature, how much faster decomposition at 650 than 500. So I am assuming this as initial temperature 500 and final temperature 650 degree Celsius, because clearly mentioned how much faster at this temperature. So we are going to give answer in terms of this 500 degree Celsius rate. So you have to add 273 here, so it will be 773 Kelvin, and 273 add here, so 6 to 850 923. मिला लेना यार please. Now if nothing mentioned, then which theory you are going to apply? Arrhenius theory. So according to Arrhenius theory, that is ln of rate at temperature T2 upon rate at temperature T1, that becomes equals to EA by R 1 by T1 minus 1 by T2. Now just you have to put values. After that you will get your answer. So ln of weight, use next page. So it is coming ln of RA 2 by RA1, that becomes equals to what is EA. Sir, actually I was using a scientific calculator, so should I use different one? But you have to use just virtual calc that is available on Play Store or it is also available in market. Wait, if my bag is here, I am showing you. नहीं इधर नहीं रखा हुआ है, कहीं और रखा हुआ है. I will show you later. That is also available in market. No, unable to find here. नहीं है अभी, आपको दिखा देंगे. आई विल शो यू इन वन ऑफ माई नेक्स्ट क्लास. Virtual calculator, virtual calci, just search on Play Store gate calci, gate calculator. Okay, just download the highest rating app and practice on that app only. Okay, okay sir. So beta here ra2 minus ra1 by ra1 and 300,000. This is e, this is r, and 1 upon t1 773 minus 1 by 923. Just one equation on this fraction unknown to you, so you can write it as ra2 ra1, and that becomes equal to exponential of 300,000 upon 8.314, 1 upon 773 minus 1 upon 923. See from where this calculation you can start in one step. अभी आपको show करते रुको, because that thing is very very important for you. Just focus here. Now ये तो चमक रहा है यार, दिख ही नहीं रहा है. आई थिंक, लेकिन यहाँ पे हम कैसे दबाएंगे? जस्ट सी, लिसन केयरफुली एंड जस्ट click that in your calci. You have to start this calculation from 1 upon 773 and minus 1 upon 923, then click equal sign, then multiplied 300,000, then again equal sign, divide by 8.314, again equal sign. You can just click, then e raised to power x you have to click. Now see, in just one exact answer that I got. रुको दिखाते हैं. 1970.707, that is 1970.71 is the exact answer. Okay, is that crystal clear to all of you beta? Shoshmit Nandi समझ गए बेटा? So it will come nearly 1970.71. This is your final answer. So you have to do calculation in your examination in just one step बेटा. एक ही step में करोगे, so that there is no possibility that you are outside the range of your gate exam, gate answer key. Okay, समझ गए? नो प्रॉब्लम, 73.15 रख लोगे तब भी कोई दिक्कत नहीं है. दैट विल बी इन द रेंज, दैट विल बी इन द रेंज. ओके बेटा आयुष, is it crystal clear to all of you my dear students? Can we proceed? Just one small topic is there. Today class is little bit large. Just one topic left, like 10 to 12 minute more class is there. 10 to 15 minutes. Can we proceed? Just tell me beta. If this is crystal clear, then just allow me to proceed. Everyone able to calculate it just in just one step? Tell me everyone, can we proceed? Crystal clear sir. Okay, now one beautiful analysis, just focus here, I am going to discuss. Suppose some reaction is happening, like you asked me one reaction. I will give that reaction again here, but see, suppose A and B is going to react, and the two different paths are available, two different mechanisms are available. Suppose you have two different mechanisms, okay, like A to A plus B, and suppose that is going to give you R plus 2s. Here also suppose they are going to give you R plus 2s, and this is mechanism 1, this is mechanism 2. Two paths are available. Suppose on theory you are writing two possible paths. Suppose two alternate paths are available for same reversible reaction. Two paths, two paths, two paths for same reversible reaction. Okay. Now suppose when the product formed chooses this path in order to get this R plus 2s. So it is not should, it is must that they are now choosing again the same path in order to give A plus B. They are not going to choose for reverse manner this path. They can't choose. They can't choose different path. They can't choose different path. Like if in this path, suppose A plus B first going to make A star B, then suppose again this A star B is going to react with A and it is going to give you A star B star plus A, and again it is going to just decomposing into R and plus 2s. So again this R plus 2 is first going to give this, then this is going to give this, then this is going to give A plus B. So they can't choose different path. If they are going A2 plus B to that R plus 1 as 2s by this path, then again the reciprocal path will remain same. This is known as principle of microscopic reversibility. The topic name is principle of microscopic microscopic reversibility. Reversibility. Okay, that means if you are choosing two, if two alternative paths are there for single reversible reaction, if one of these paths is preferred for the forward reaction, then the same path will be, not will be, must be used for that backward reaction. This is principle of microscopic reversibility. Okay, you can write here, if one of these paths, one of these paths is preferred, definitely the kinetics of both paths are different and the condition that you are going to apply there for that preferred path. So preferred for the forward reaction, the same path must also be preferred for the reverse reaction. And my dear student, this is known as principle of microscopic reversibility. Is it crystal clear, or you want some more example, real examples, or is it crystal clear? You want any real example? कुछ एग्जाम्पल आपको दें क्या रियल वाला? First tell me till now, is it crystal clear to all of you? एग्जाम्पल सर, वो तो पता ही था, जब बोल दिए तो मांगोगे ही. Example sir, okay, okay, see I'm giving a beautiful example to you. This one clear na? Can I change my slide? Okay, so manufacturing of ammonia. Example, manufacturing of ammonia. The process name is Haber-Bosch process. You will see this process in detailed manner in chemical technology. Okay, simple reaction if you want to write, my dear students. So here reaction is N2 plus 3H2 फॉर्मिंग, एक काम करो पहले दोनों इकट्ठे लिख लो उसके बाद से अलग अलग कर लेते हैं. And it is going to form 2NH3. Clearly the reaction is reversible one. And if you want to want more, then iron promoted catalyst is there. Iron promoted catalyst is there. And reaction is reversible and exothermic one. Okay, sometimes you can also see FeO, and in detailed manner you will see in chemical technology what is happening with that catalyst there. Now clearly for this reaction, if you want to write forward path, so forward path is N2 plus 3H2 forming 2NH3. And here if you want to write backward path, so my dear students, the backward path here is 2NH3 forming N2 plus 3H2. Now suppose someone going to assume and going to see and assume that the forward path is elementary one. Forward path is elementary one. So is it possible, my dear students, that forward path is elementary? You don't know anything about this reaction. You don't know. You had not done your experiment yet. You had not done your experiment yet. But just tell me, my dear students, if someone assumes this is an elementary reaction, so are you able to assume it? Just tell me yes or no. Just tell me yes or no. Not possible because molecular would be 4 then. Yeah, absolutely correct. So clearly here not possible. Here if you are assuming that it is elementary. So clearly this assumption is wrong here. Now, but suppose someone is going to assume the same thing, that the ammonia is going to give you this nitrogen plus hydrogen. This is an elementary reaction. Then my dear student, this can be correct na yaar. Just tell me yes or no. Just tell me yes or no. Just tell me, my dear students, yes or no. Just write in comment section everyone. It may be correct na. You don't know anything. You don't know anything. But it may be correct na. You had not done. You had not performed experiment here. You had not performed experiment. Okay, you don't know anything about reaction. Okay, so it can be. It can be na. It can be correct na. Hmm? Sushmit may be correct, sir. Shivatun may be. Divyansh Ayush, no. Divyansh and Ayush, why no, yaar? So please explain why you are telling no. Give me reason. Support your answer. Please support your answer. Why you are telling no, sir? That's why you can't write it that it can be elementary. Okay, because I had not done experiment. I don't know anything about. I don't know anything about this reaction. Suppose. Okay, just assume it. So in that case, are you able to write can be? अब तो लिख सकते हो ना यार, हैं? Just tell me. You can write ना यार. In that case, you can write. Ayush Divyans, please tell me everyone. Everyone यार थोड़ा fast comment किया करो यार. Lecture time is over. But I think still I need 4 to 5 minutes. So please tell me immediately. Hmm? Yes, sir, can be. Yes, sir, can be. Yes, sir, can be. So, my dear students, can't. Still can be, you can't use. Ayush कहेगा, sir, first you pressure that please tell me. Sir, you pressurized me to tell me can be. And now you telling it is not. My dear students, how you can be? Just you had seen principle of microscopic reversibility. If you are telling can be, it can be elementary. In that case, it must also be elementary, Nare bhai. Please tell me, are you getting my words? Are you enjoy this concept? If you are telling can be, so it also can be na. But is it possible that four molecules are going to collide in just one step and going to give you product? Are you getting my words? So if a forward path is the multiple step one, so the reverse path is also the same na. Huh? In my previous class you asked me, sir, the reverse one is elementary or not elementary. See, this is the reason. Are you getting my words? Please everyone tell me, beta, is it crystal clear? Is it crystal clear to all of you? So if this is not, it can't be elementary one. If it can't be elementary one, then it also can't be elementary one. Even from here, if you are seeing 2ns3, molecularity is still 2, so you can't still define its molecularity and other things, because this is also multi-step reaction. Its mechanism is not defined by single step. Okay, please everyone tell me, is it crystal clear to all of you? Crystal clear, sir. क्या बात है. So my dear student, this is known as principle of microscopic reversibility, that according to this principle, if one of these paths is preferred for the forward reaction, then same path must, it is must not should का मतलब कि हो भी सकता है नहीं भी, must मत होना ही चाहिए. In Hindi, just I translated my last line, so English learners don't worry. So if one of these paths is preferred for the forward direction, then the same path must also be preferred for the reverse direction. This is principle of microscopic reversibility, and I hope now everyone feeling comfortability with this topic also. Okay, done. No doubts at all, beta. कुछ पूछना है तो फटाफट पूछ लें, because I will end this lecture in next 2 or 3 minutes. Everyone crystal clear? Crystal clear, sir. No doubt, sir. So today, my dear student, we had completed transition state theory as well as collision theory in too much depth. Few things I also explain later from thermodynamics about a temperature dependent term, but not right now, later, after a few more concepts, after discussion of few more concepts. For this time, you can assume like the temperature dependent term is, the main part is completely over. Okay, and you had also seen the numericals. Few numericals I will give as homework by tomorrow from collision and transition state theory. कल आपके स्लाइड में स्टार्टिंग में लगा देंगे, एंड आई विल गिव एज होमवर्क along with answer of the questions. If any doubt, you can ask me in live doubt clearing session. Okay, so चलो, so lecture को end किया जाए बेटा. किसी को कोई डाउट नहीं है? One time, if you want to see today's all slides, then just 30 second I can show you, and still you can write your doubts. If you have doubt, just ask me. Okay, so today you had started collision theory, beta. Assumptions, the main assumptions here, hard sphere molecules are there, and because of this I told you that quasi equilibrium is not going to occur here in this case, but if forcefully in options they are asking you, then you can correct there. Okay, otherwise if you are going to raise hand, maybe gate authority is not going to listen your words. Okay, and they can show you some book, other you see here this line is written, and वो आपको शो नहीं करेंगे, बस आपकी बातों को निगलेक्ट कर देंगे. Okay, sometimes it happens. So if forcefully asked, then you can write here. Okay, then you had seen collision theory and simple mathematical dealings. नाउ वन मोर थिंग, वेट बेटा, वेट, अच्छा हुआ, एक एक चीज और बची हुई है, जस्ट वेट 1 minute. My dear students, just you had seen that k now can be written as k naught t, or just you can write this k as a proportional to t raised to power m e raised to power minus e a by rt. So you had seen that m is equals to 0 for Arrhenius theory, m is equals to 1 by 2 for collision theory, and m is equals to 1 for transition state theory. Okay, that means m is, if someone asks you, then it is greater than equal to 0 and less than equal to 1. This you can write, but for few more theories are there, exceptions, few more theories are there, few more theory suggest m can be 3 to 4, 3 से 4 तक की वैल्यू भी कुछ थ्योरीज में आती हैं एंड एक्सपेरिमेंट से भी वेरीफाइड होती हैं. Okay, so n can be more, but for you, if they are going to ask in examination, you are going to give this answer, beta. Don't use exception. You are going to use this answer for gate examination. Okay, done. Okay, chalo. So very happy good night to all of you, beta. So I hope that everyone enjoyed today's lecture. Just tell me that everyone enjoyed. No doubts. All clear. So at last, I just want to say the same thing, beta. If you want great rank, rank 1, rank 100, any rank between these ranks, so revision is the key for success. I must do Moisen daily. 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 But don't forget to revise your notes every day. In this manner, definitely you are going to get your dream job. All the best, beta. Take care. Love you all. Enjoy it, sir. Okay, beta. Thank you. Okay, but Ayush, it can take 6 to 7 days more to share last practice sets, starting practice sets answer key shared by me. The last one practice set answer keys, just I'm unable to find in my laptop. So maybe I have to solve it again. After only after that I will give you answer keys. So जो आखिरी के 4 या 5 प्रैक्टिस सेट थे उसके आंसर कीज आपको थोड़ा लेट मिलेंगी. आप अपने आंसर्स को जस्ट यू हैव टू सबमिट योर आंसर इन टेलीग्राम. ओके, आई विल चेक लेटर. Thank you, sir. You're all welcome, beta. Take care.